Hey everyone, this is Anson. We're back with a brand new video. A lot of you have seen my Express.js tutorial that I uploaded about 2 months ago. It covers all of the core fundamentals that teaches you how to get started with Express.js, from building simple API endpoints all the way to writing integration tests. Now, a lot of you actually asked for that same tutorial, but with TypeScript. Now, I am going to show you all how to set up an Express.js project with TypeScript, but I am not going to remake that whole tutorial with TypeScript because I think there's a lot of overlap and there really isn't too much of a difference. I think the biggest portion of it is just setting up the project in TypeScript for Express. So I'm going to try to keep this video as short as possible, but also as informative as possible, showing you how to set up your project from the ground up using TypeScript for Express.js. And then as you go along the video, I will show you examples of how to do type annotation for your functions, for your arguments, objects, whatever it is. And then you can start to piece everything together. So that way you'll build an intuition on how to convert your entire Express.js project into TypeScript. So again, this is not going to be the same 8-hour tutorial just done in TypeScript. I'm just going to show you all the relevant things that you will need to do so that way you are prepared and you'll know how to convert everything over. So let's go ahead and get started. What I'm going to do is I'll set up a project right now. I'm going to call this Express.js TypeScript example tutorial. I know that's a long name, but we'll just leave it like that for now. I'll cd into that folder. And what I want to do is I want to set up a package.json file. So we're going to type npm init-y, and then we're going to install our dependencies. So there's a few dependencies that we will need to install. So I'm going to first install Express.js. So npm I express, so we just have it installed. And now the rest of our dependencies that we will be installing are just going to be developer dependencies. So the important one that we need is TypeScript, because obviously we're trying to set up a TypeScript project. So we need to make sure we install TypeScript into this project. So what we want to do is we want to type npm I, but we want to install TypeScript as a dev dependency because TypeScript is supposed to be used for development only. So when you actually deploy your application to a production server, you don't want to actually run TypeScript on the production server. You want to actually run transpiled TypeScript into JavaScript on the server. Okay, so we'll install TypeScript as a dev dependency. So we're going to type npm I-d, which means dev dependency, TypeScript. So this will install TypeScript as a developer dependency. I'm going to open up Visual Studio Code, and we'll see our dependencies are listed over here in its own category. So we have dependencies and we have dev dependencies right over here. And if I look in the node modules folder, you'll see that if I go into this .bin folder, you should see this tsc. This is a binary. This is an executable. And this is going to be the tsc script that we're going to be using to do things such as building our project to transpile all the TypeScript code into JavaScript code and other things. Okay, so now before I do anything else, I want to show you how we would actually write our Express.js project in a TypeScript file. So we're going to right click and create a new folder, and I'll call it source. And then I'm going to create a new file. Instead of naming it index.js, we're going to name it index.ts. So index.ts, just like that. And now what I'm going to do is I'm going to import Express from Express. And I'm going to go ahead and create my Express app instance the same way that I would do it in JavaScript. So const app equals Express, and then call this function. And then now I'll just declare a variable for the port. We'll assign it to port 3000. And then now what I'm going to do is I'm going to call app.listen. Now you'll notice that it's not picking up the listen method in IntelliSense. if I actually hover over this app variable, you'll see that the data type is any. So TypeScript actually does something called type acquisition, and we need the appropriate type files or the type definitions for our Express package. And that's also another reason why we don't have this method appearing after we try to reference the app variable, because we need the type definitions for Express. And most packages will have these type definitions. You just need to install it. So what we'll do is we'll go back into our PowerShell, and I'll type npm I, and then we'll use the -d flag because this is going to be a dev dependency as well. And then we're going to do @types, and keep in mind that all of your type definition packages that you will install will be prefixed with @types. Okay, it's pretty much the standard for the npm registry. So @types / and then the name of the package, just like this. Okay, there we go. So now we've installed that, and all of your type definitions will actually be located in the node modules folder inside this @types folder, and you'll see that it did install not only the ones for Express, but for a few others as well. Okay, we have Express right over here, and look what happens now. When I hover over app, you'll see that it is no longer of type any, but of type Express. So if I try to do app.listen, it'll actually pop up under IntelliSense, and it'll show other methods as well. Let's go ahead and pass in the port, and then a callback, and we'll do console log running on port, and then ports. So again, everything that I've done so far is no different than how I would set up a simple Express.js project using just plain JavaScript in an ESM module or ES module. So one more thing that I will mention is sometimes your type acquisitions may not reflect automatically. So if you hover over app and it's still of type any, what you can do is you can go to your command palette. So if you just go to view and then select command palette, or just hit Control-Shift-P on your keyboard, and then over here you want to type restart TS server. And for my case, I already have it over here because I recently used it. So I can just click on that, and it will restart the TypeScript server for you. And you want to do this oftentimes. The TS server may be lagging and it's not automatically reflecting your configuration or your types in this case. So you definitely want to do that. Now, right now, if I wanted to run this index.ts file, how would I do that? You're probably wondering, well, couldn't I just use the node command? So let's just type node and pass in the index.ts relative path. And you'll see that we immediately get an error, and it's complaining because we're trying to load an ES module. Okay, by default, TypeScript uses ES modules, and we're trying to use the node command, which assumes every single file that you're trying to run is going to be common.js, unless if you set the type to module in the package.json file. We don't obviously want to use common.js with TypeScript. That wouldn't really make any sense, and I don't even think that would work. So what we want to do in order to actually run our code, well, there's actually two ways that we can do this, okay? What I'll do is I'll show you how we can actually transpile everything from TypeScript to JavaScript, and then use the node command to run the actual JavaScript files. And then I'll show you how we can use node ts, which is pretty much just a node interpreter, but for TypeScript. So in order for us to actually transpile our code, we need a tsconfig.json file. So we don't currently have one, but we can easily generate one. So remember how earlier we installed TypeScript, and then I showed you in this .bin folder, there's this tsc command, which is pretty much the TypeScript compiler, which is what it stands for. So we want to run this tsc command, and to do that, what we can do is we can type npx tsc, and this will basically use the local installed tsc binary that you have in your node modules folder over here. If you have TSC or the TypeScript compiler installed globally, then you don't need to do this, but I would recommend avoid installing TypeScript globally because there might be issues with versioning sometimes, so it's just better to use TypeScript locally. So make sure you type npx tsc and then --init, and this will generate a tsconfig.json file. Now, when you click on this file, there's going to be a lot of different configuration options. It's going to seem very overwhelming. don't worry, I'm going to focus on the ones that are going to be very important. Okay, so the ones that are extremely important are not commented out. So for example, target, it's currently set to ES 2016. So that's the version of the JavaScript language. You can set it to whatever you want. We'll just leave it alone and set it to ES 2016. And then you'll see that there's module. So again, this entire tsconfig.json file is everything to do with how you want TypeScript compiler to behave when it comes to transpiling your code from TypeScript to JavaScript. So you might see over here, it says module CommonJS, and you're just pretty much telling the compiler to transpile everything to CommonJS. You could change it to something else. You could have it transpile to ES6 or ESNext. It's up to you, but we'll leave it as CommonJS for now. There is also, let's see what else is there. There's also these other uncommented ones. We're not going to focus on that, but the one that I want to focus on is this. So we want to look for this root-dir, which is currently commented out. We're going to uncomment it, and we're going to set the root directory to the source folder. Okay, because all of our TypeScript source code is going to belong inside the source folder, so we want to set it to that. Okay, we also want to set the out_dir property, so we want to search for that, and it's also currently commented out, so you want to uncomment it. And this out_dir is where all of your transpiled code, so all of your JavaScript code, is going to be generated to. So you want to name it something that is going to make sense. Most oftentimes it'll be named something like dist or build. You can name it whatever you want as long as you can recognize it. I'm just going to name it dist. Okay. And so pretty much when we build our source code, our TypeScript source code, it's going to transpile all that TypeScript code and then place it inside this auto-generated dist folder. Okay, so hopefully that makes sense. There's a couple other things too that we can uncomment. So for example, when you're using TypeScript, there's some compiler options that you can set to have it do certain checks for you. And you know, when you use TypeScript, there's a lot of important reasons on why to use TypeScript. One of them is because you want to have more strict enforcement of writing code. So for example, you want to make sure that your data types are properly typed. So we want to make sure we have no implicit any set to true. We'll uncomment that out, and we'll also uncomment out strict null checks. So this will ensure that if you're passing something that could possibly be null, it won't allow you to compile your TypeScript code at all. We can do the same thing for strict function types and a bunch of other stuff, but we'll just leave it like this for now. We'll keep it nice and simple. So this is all we really need to worry about for now. So what I'll do is I'll close this tsconfig.json file. And now let's go ahead and actually try to transpile our index.ts file. So in order to actually transpile everything, we want to basically build out this project over here. So what we can do is we can type npx tsc and then --build, and it's going to use all of the options that we have in our tsconfig.json file. So when I hit enter, you're going to see that the dist folder was just generated, and you're going to see inside this folder we have this index file, but now it's named index.js instead of index.ts because it's transpiled down from TypeScript to JavaScript. And you'll notice that there's a huge difference between these two files, right? Like there's a lot more lines of code, and you can see a lot of the stuff that you see in the transpiled code is a lot of these things are code that you would never actually really write even in a JavaScript project as well. Okay, so you can kind of see how cool all this stuff is. But now what I can do is I can actually use the node command to run not the index.ts file, but the index.js file. So all we need to do is just type node and then pass in the path, the relative path to index.js. So that's going to be /dist or whatever you name that out_dir folder, and then index.js, just like this. And you can see that, let's see, it's saying that it's currently in use, which it shouldn't be. Let me fix that real quick. Okay, let me run the command again. I just had to terminate some of the node processes that were running in the background. And there you go. Now it's running on port 3000. So we can go to our browser, and then we can see that over here, it does work, and it's saying cannot get, which is fine. Okay, wonderful. So it's working. All right, so obviously I don't want to have to keep on, manually typing out this command all the time. So let's set up some scripts, which is very, very important. So let's set up a build script first, which is very common in every single TypeScript project. And it's basically just going to be an alias for this tsc-build command that I just set up. So what I'm going to do is I'm going to type tsc, and we don't need npx anymore, because what happens is inside your package.json file, when we run the build command, it's going to go ahead and look inside the node modules folder, and it's going to basically just execute this tsc binary. So we don't need npx to do that. Okay, so we're just going to type tsc and then -- build, and then that's pretty much it. There also are a bunch of other options you could pass into the build script or the tsc command if you wanted to. I recommend you look that up in the TypeScript documentation. There's a lot, so definitely check that out if you want to. And let's see, we have a build script now. Let's also set up that start script. So we'll set up a start script, and this is just going to be an alias for node, and then it's going to run the index.js file. So let's do that, node, and then / dist index.js, just like that. Now I'm going to show you how we can actually have our project, our TypeScript project set up, so that way we can use Nodemon, which many of you are definitely familiar with Nodemon. It basically will detect file changes and restart the process, so you don't have to manually restart it over and over and over again. Okay, so we're going to use Nodemon. So what we'll do is we'll go into our terminal, and I'll install Nodemon as a dev dependency. So npm i-d Nodemon. And now what I'm going to do is I'm going to set up a dev script. So I'll call it start:dev. You can just call it dev if you want to. Many people just leave it like dev, but I'll just call it start:dev. And then we're going to have this be an alias for Nodemon. And then this time we're going to pass in the path to our index.ts file. Okay. So let's try to run that script. So npm run start:dev, and you'll see that it's going to throw an error now. You'll see that it says ts node is not recognized as an internal or external command. And the reason why this is happening is because Nodemon for a TypeScript project needs ts node, and ts node is basically just a Node.js interpreter just for TypeScript. So we're going to want to install ts node. So let's type npm i-d ts node. So we're installing it as a dev dependency. And again, you can see inside the node modules folder, inside the .bin folder, you'll see that Nodemon is installed right over here. That's the binary, that's the executable. And then we have ts node over here. So now what I can do is I can just rerun that script, that dev script, and Nodemon will actually work because it's going to see that it's trying to run a ts file. So it's going to use a ts node interpreter. Okay, you can also just use the ts node interpreter. So let's type npx ts-node, and then you can also just run that TypeScript file like this. But of course, this is not going to detect file changes, so you will need to manually restart your application whenever you make changes. But there's no real reason for you to do this, and ts node does not have options for watch options, so that's why we need to use Nodemon for that. Okay, so again, hopefully all of this stuff with the scripts makes sense. I'm not going to do the test script right now. I will do that later on towards the end of this video, where I show you how to set up Jest with TypeScript for your Express project, so stay tuned for that. But let's go ahead and exit out of this process, and let's move on. So we have 3 major scripts that are set up. So again, for development, we're going to use this start:dev script. So that way, as I am making changes to my code, so let's start this up again. If I just do this app.get, you'll see that it will restart for me automatically, and I don't have to exit out the process and start it again, which is pretty tedious and annoying. We also have our build script. So this is important because before you actually deploy your application, you need to make sure that you are building your whole project, which means you're transpiling all of your TypeScript source code into JavaScript code. And then on the deployment server, you're going to go ahead and run this start script, which will just basically use the node command to run your index.js file because that's the entry point to your application. And that is how your production server or your deployment server is going to serve that application to your clients. Okay, so these two commands are very important as well for any deployment server that you're going to deploy to. So now what I want to do is show you some examples of how we can type annotate our functions and arguments in Express.js. So let's say I want to set up a GET request. So I'll reference the app variable and I'll call app.get, and I'll set up a simple path, so /API/users to get all of the users. We'll need our request response handler, which is going to be a callback function. And then our callback function, remember, is going to need the request argument and the response argument. And then sometimes you might need to work with the next function. So I'll just add that in just so that we cover every single case. Now, right over here, I can go inside the callback function's body and I can reference request, and you can see that IntelliSense will pick up all of the properties, all of the methods, and I can do whatever I want. Okay, I can reference request.query to access all the query parameters, request.params to reference all the route parameters. Nothing different than a regular JavaScript project. Same thing with the response object. I can call response.send, and I can send back an empty array and do whatever I want. Okay. Now in this situation, I don't necessarily need to type annotate the request argument or the response argument or the next argument, because TypeScript, remember, does something called type acquisition, and it's going to map the appropriate type to these arguments. So if I hover over here, you'll see that the type annotation over here is this request, and this is actually an interface. Okay, and you can read a little bit more about this. It can be confusing sometimes, but this request is in fact a generic type. Same thing with this response over here. Okay, I can actually right click and then click on go to type definition, and you can see that it takes me to this index.d.ts file. Remember, this is a declaration file. And then we have this request, which is an interface, and there's a lot of stuff that's going on here. It is going to look very confusing sometimes. Again, you don't have to worry so much about reading through all this, but just from scrolling through, you can see that, oh, okay, I can see that it has all these methods. I can see it has, let's see, these properties. Again, there's a lot of stuff. It might be confusing. Don't worry so much about it. Okay. Now, in terms of type annotating your arguments, what I could do is I could type annotate this with the request, and you want to make sure that when you do type annotate it with the request interface, that you're doing it with the interface that comes from the Express package, because right over here, IntelliSense is picking up this request interface, but this is actually not the correct request interface. This first one that's right over here. If I try to go to the definition, and if I click over here, you'll see that this request interface is actually coming from this node globals.d.ts package, and this is not the correct request interface. And if I actually left it like this, it's going to actually complain about how this argument is not the correct argument itself. Okay, it's not the correct type. So what you want to make sure you do is you type annotate it with the Express interface over here. So when you click over here, whoops, let me do that again. When you click here, it will import it from the Express package. Okay, and then now you can see that the error goes away. Same thing with the response object. When you want to type annotate it, you want to make sure that it is coming from the Express package. So just like that. Okay, and then we'll do the same thing for the next function. So the type annotation will literally just be next function. And then you can always right click each one of these, import, and then click on go to definition. And it will take you to the Express package for the types, and it'll take you to the declaration file, and it'll show you the interface itself. So now I'm going to show you an example where we can set up a more complex file structure with our Express project, because not all the time you'll want to have all of your API routes defined in one single file, in our case index.ts. So what I'll do is I'll use a router to set up a user's router, and then I'll show you how we can create a proper file structure. So I'm going to go into the source folder. I'll create a new folder called router or routes, and I'll create a new file called users.ts. And again, this should be very similar if you've learned about Express.js and you've learned about routers in Express.js, so this shouldn't be anything new. We're going to go ahead and import the router from Express. We're going to create an instance of the router by calling that router function just like this. And then I'll export the router as a default export. And I'll go ahead and set up a route with the router. And then we'll need a request handler, but instead of just passing in an anonymous function just like this, we're going to actually pass in a named function that is going to be imported from a different file that we'll create. So I'm going to remove this. Before I do anything else, I'm going to go into my index.ts file. I'm going to import that user's router from routes users, just like this. And I want to register this user's router. So I'm going to go down over here after where I have initialized my Express app. And I'm going to go ahead and call app.use. And the first argument is going to be the path prefix. Okay, so the prefix is going to be /API/users. It could be whatever you want, but I'm going to do /API/users. And basically every single route that is going to be registered in my user's router will be prefixed with /API/users. So for example, this router.get path, this is just a / path, but in order to actually access this route, you need to actually go to /API/users, just like this. So if I wanted to access, let's say router.gets, let's say we have a route parameter of ID. So let's say we want to get a single user by its ID, then the actual API would be /API/users, and let's just say 1, 2, 3. Okay, so hopefully this makes sense. Again, you should know this already if you've worked with routers, but I just want to mention it just in case some of you are not familiar with this. So I need to pass the user's router as an argument, the second argument, to app.use. So I've registered my router right over here. And now what I need to do is I need my route handlers. Okay, so we're going to create a new folder, and I'm going to go ahead and call it handlers. And I'm going to go ahead and create a new file, and I'll call it users.ts. Personally, for me, I like to map or match the file name for handlers with the route, so that way I know which file contains what handlers for which router. You don't have to do it this way, but this is something that is common. I personally like to do it because it helps me recognize each file and where everything belongs. So now what I'm going to do is I'm going to create a handler function, one for API/users and one for API/users/ID. So we'll create the function and we'll also export it. I probably don't need async right now, but in case if I did need it, I would add the keyword in front of it. But we'll just do export function, and I'm going to go ahead and give this function a name. So I'll call it get users, and then I'll pass in the arguments, and the arguments are going to be the same exact one that you would pass in for your anonymous function. Okay, so remember we have our request and our response arguments. And if you needed the third argument, the next function, you would pass that in. So I'm going to go ahead and do that real quick. So request, response, and we don't need the next function, so I'm going to omit that. So now you'll see right over here, if I were to try to reference request, you'll see IntelliSense doesn't pop up. It doesn't give me any of the properties that I can select from. Okay, and in fact, if I try to reference it like this, nothing would actually happen, but you'll see that we have these errors over here. It's saying parameter request implicitly has an any type. So what this means is that you need to make sure you are properly type annotating your arguments. And the reason why this error is happening is because in our tsconfig.json file, we have this no implicit any set to true. And you don't need to have this set to true if you don't want to, but I recommend you do because, again, you most likely do not want to use the any type, because personally, if you're going to use TypeScript, there's no reason for you to use the any type. Sometimes in very specific circumstances, you might need to use it, but probably in like 95% of the times, you don't want to use the any type. If you can get away without using the any type, then you should. But again, it kind of defeats the whole purpose of using TypeScript if you're just going to annotate everything with the any type. Okay, because what that's doing is it's setting the type to literally any, and you don't have proper type annotation. So I could set it to any and this error would go away, but that's kind of like not really using TypeScript the TypeScript way, if that makes any sense. So what we want to do is this. First, I'll show you how to disable this. So all you have to do is just go over here, no implicit any, and set this to false. And then now you'll see that these errors should go away. However, if you hover over it, it will still show you this. It's not really like an error warning, but it's just going to show you that this is not, it's not necessarily a problem. Like your application still will build and it will run, but it's just going to note that for you in case if you wanted to do something with it. Okay. But what I'll do here is I'm going to properly type annotate these arguments the same way that I did in the first example in our index.ts file. So we're going to go ahead and use colon, and then we're going to import request from express, just like this. And then we'll do the same thing for response. So we'll import response from express. Remember, these are interfaces that are being imported from the express package. So now we have proper type annotations, and I can reference request, and I have all of the properties, all of the methods if I needed to call anything. Okay, pretty straightforward stuff. And then same thing with the response. I can go ahead and do response.send, and we'll just send back an array. Okay, so hopefully this makes sense. So now what I can do is I can go back to my user.ts file in the routes folder, and I can pass this getUsers function as an argument to this router.get call. So as the second argument, I'm going to go ahead and pass getUsers, and I'm going to import that, and that's going to be imported from the handlers/users.ts file up over here. And we're passing that as a callback function over here. And again, this is no different if you were to literally just copy this whole thing and pass it in as an anonymous function right over here. Let me see if I can clean this up a little bit. Let's import request and let's import response, right? And you can see there's no difference over here. The only difference in this situation is that you're now using an anonymous function and not a named function. And the downside to that is, let's say, for example, if you wanted to, let's say, reuse this function if you needed to, then you would not be able to kind of like extract that function from this user.ts file from the routes folder. You would have to basically redefine the entire function and re-implement the entire logic. And also, it would make it a lot more difficult for testing, because how are you going to test an anonymous function? Because you can't import a function that doesn't have a name. Okay, so again, I recommend you avoid using anonymous functions because it just will cause a lot of headaches down the road. Okay, and it makes it a lot easier for testing, which again, I will show you how to do later on. So definitely do this approach where you create the actual function itself, type annotate it, and then import it and pass it as an argument. Okay, so hopefully this makes sense. Let's go ahead and quickly do the same thing for our second router.get. So let's go inside our handlers users.ts file, and I'll just go ahead and copy this function, and I'll just rename it to getUser by ID. And I'll just leave the logic alone for now, and I'll just import getUsers or getUser by ID, pass that as an argument, and I'll just actually send an empty object instead of an array for now. Okay, so now let's just test everything out. Remember, we have already registered our user router. So let's go ahead and run our application and test everything out. So npm run start:/dev. Okay, and let's make sure everything is good. No errors. So now what I'll do inside my browser, I'll go to localhost port 3000, and then we'll do /API/users. And you'll see we get back our empty array. If I try to pass a route parameter, so let's just do 1, it's going to give me back that empty object. So we know that both endpoints are working fine. So now I want to show you how we can type annotate request bodies, because this is going to be a common thing where you have, let's say, a post request set up where you want to send data from the client to the server. And then you also want to make sure that when you reference the request body, it has the proper type annotations. So what I'll do first is I will go ahead and set up a post request. So let's go over here and we'll do /API/users. And then we'll do router.post. So this will be for creating a user. And we'll just leave it like this. And then now we'll just need to create the request handler. So I'll go down over here and I'll call this function create user. And let me go ahead and just quickly import that in the user.ts routes in the routes folder for users.ts, create user. Okay, and let's go over here and let's do request, response. Okay, so let's say, for example, if I needed to reference request.body, you can see over here, if I hover over, it's going to show me that this is the current type annotation. And this is a lot of stuff to understand, but ultimately what you need to know is that if I try to reference a specific property, I don't get IntelliSense on that. So let's say, for example, I expect that the request body is going to have a username, email, and password field. Okay, but IntelliSense doesn't show any of that, and TypeScript doesn't know that these fields exist on the request body. So how do I actually get it to work where the fields are showing up on the request.body object? So a couple things that I want to mention first is you always want to make sure that you are validating your request body first. So we're going to assume that our data has been validated already, and that is typically done in a middleware. So again, I assume that many of you have seen my Express.js full course where I go over validation. If you haven't seen that already, go check it out. It should be pretty straightforward. Again, middleware is not any different in TypeScript versus JavaScript, so check that out. But we're going to make the assumption that our data is already validated. Okay, so what I'm going to do is I'll create a new folder and I'll call it, let's do DTOs. Okay, so DTOs stand for data transfer object, or DTO stands for data transfer object. And what DTOs represent is basically a way for you to represent data that is being transferred from one party to another. In this situation, we are technically, transferring data from the client to the server, or you could transfer from server to server, whatever it is. Okay, so we use a DTO to represent that. And all a DTO is just either a class, an interface, whatever. Doesn't really matter. So we're going to go ahead and create a new file, and I'll call it, let's do create user dot, or let's do .dto.ts. And again, you don't have to do this. I personally like keeping everything organized, so that way I know where everything is what and I know what is what. So what I'll do here is I'll actually use an interface. So I'll do export class create, or whoops, not class, interface, create user DTO. And this is where I want to specify each field. So I'll go ahead and do username, string, email, string, and then password, string. Okay. And you'll notice how I am not marking these properties as optional like this, because again, we're making the assumption that the data has already been validated already. So if I actually right click this request interface and go to type definition, you'll see that if we look over here, we have our interface, and you'll notice that there are these angle brackets right after the name of the interface, this request interface. So this is known as a generic. Okay, and I highly recommend you understand generics if you don't already, because you're going to be working with them a lot in TypeScript, or really with any programming language that has object-oriented features, such as generics. It's not specific to TypeScript. Okay, so if you already know generics, that's great. If you don't, definitely study that. But if you look right over here where this rec body is, this is the third, I guess we can call it a parameter, a typed parameter, okay? And basically what we want to do is for the third parameter, we want to set our request body type. So currently it's set to any, but we want to change that. So what I'll do is for this request over here, I'm going to go ahead and provide a pair of angle brackets. And for the first two, I'm going to pass in empty objects. But for the third one, I'm going to pass in this create user DTO interface that I just defined. So create user DTO, and that's going to be imported from our DTOs/create user.dto file. And now what I can do is I can reference request.body. And if I just reference by using the dot operator, you'll see that IntelliSense or TypeScript now knows that these three fields exist on the request.body property. So I can reference all three of these fields however I want, and I can do whatever I want with them. Okay, so hopefully that makes sense. If I were to remove this and then just leave it as an empty object, you'll see that TypeScript thinks that this request.body property is of type any, and it's not going to recognize any of the actual properties, or not of type any, but of type empty object. Okay, so again, hopefully this makes sense, and hopefully you now know how to properly type annotate the request body. And again, you could do the same thing for query parameters too. So if I wanted to, let's say, type annotate query parameters, so right now you can see that when I reference request.query, and if I try to reference the query object, nothing shows up. So to do that, again, I can look over here in the generic request type, and I can see over here that it seems like for query parameters, it's going to be the fourth typed parameter. So right over here. So what I'll do is this. I will go ahead into, I guess we'll do it inside DTOs. Or you know what I'll do instead is I'll leave DTOs specifically for request bodies. I'll create a new folder and I'll call it types. And I'll create a new file and I'll call it query params.ts. And I'll do this export interface, create user query params, just like this. So just as a simple example, let's say after we create the user, we want to auto log them in. So for a query parameter, I'll just do something like login after create. And I want this to be an optional query parameter. And I'll set this to be a Boolean. Of course, when you pass in the query parameter from the client to the server, it's actually going to be a string. So you need to make sure you're properly parsing that string or that query parameter to a Boolean value. Okay. Well, again, we'll just assume that it is a Boolean. Well, we'll assume that it's parsed. So let's go ahead and take this interface, and remember, it's the fourth typed parameter. So we'll go ahead and do that real quick. And I'll save. And now if I reference query, you'll see that this login after create property shows up in the query object itself. Okay, and I can reference it and IntelliSense picks it up. So that's good. Okay, of course, even if you didn't type annotate these things, you wouldn't really get an error and you would be able to reference it. But I would say for good practice, it's worth type annotating these properties. And again, you can also do the same thing for let's see, you should be able to do the same thing for your route parameters. I believe that's for the first typed parameter. I'll just do a simple inline one real quick, just as an example. So let's just do ID string, and let's just see what that looks like. Request.params. And yep, I was right, request.params ID. And if I were to just leave this as an empty object, you'll see the ID does not exist on request.params. So hopefully that makes sense. So yeah, go ahead and be creative with this. Play around with the other two request handlers and try thinking of things that you would want to do for your own API. So that's how we type annotate our request body, our request parameters, and our query parameters. Now, sometimes you might want to have explicit return types for your response. So let's say, for example, after we create a user, we want to send back the actual user that was created, of course, without the password field at all. So in this situation, what I might want to do is I want to set the status code to 201 and then send back the user record. Okay. Right now, it's allowing me to send literally anything I want, but I want to make sure that it is only sending back a user record to the client. So much like the request interface, I can also type annotate my response interface. If I right click response and go to the type definition, you can see that we have this response interface, and it's very similar to the request interface in the sense that it is also a generic and also has typed parameters as well. And you can see over here we have this res body, which is currently set to any. And what I could do is I can create a user record or user type and then use that as the typed parameter. So that way when I call response.send, it is going to expect us to send back a proper user type. So what I'll do is in my types folder, I will go ahead and create a new file, and I'll just call it, I guess, response.ts. And typically if you have, like, let's say a database set up, or if you're using something like, let's say you're using TypeRM or Prisma, you can actually reuse those types that were already created based off your schema. I don't have a database set up right now, so I'm going to have to create this from scratch. But I'll go ahead and do this. I'll do export, and I'll use interface, and we'll do created user, or I'll just do user. And let's go ahead and do this. ID, number, email, string, let's see, username, string, and of course we typically would not want like a password field, so I'm not going to include that. We'll just leave it with these three fields for now. And what I'll do now is I will go into my create user function, and for this response, I'm going to provide a pair of angle brackets, and for the first parameter, for the first type parameter, I'm going to set that to user, and I'm going to import that from my response.ts file in the types folder. And you'll notice how the moment that I actually provided that user as a type, we now have this error over here. Okay, if I were to remove that, you'll see there's no error. But if I put that back there, you'll see that we have this error. If I hover over, you'll see the argument of type empty object is not assignable to parameter of type user. And you'll see that it's saying that it's missing the following properties from type user: ID, email, and username. So again, it's basically telling you that the types are not the same. They're not compatible with each other. You're trying to send back an object without the ID, email, or username. And that's not okay. You need to make sure you send back the proper user type with all three of those fields. So what I'll do is I'll just go ahead and provide those fields. We'll just hard code them as an example. But of course, in your situation, you might grab it from a database, filter out the password, and then send it back. So ID, we'll just do ID of 1, username, we'll do Anson, and then email, we'll do anson@ansontodev.com. And we're good to go. So now what I'll do is, let me also just return this response.status call. And I'm going to go ahead and take my create user function, and I've already passed it as an argument to router.post. And we already have our user router registered. So what I'll do is I'll go into Thunder Client, and I'll go ahead and create a new request. I'll go ahead and select post. And in case if you don't know what Thunder Client is, it's an extension in VS Code that you can just download. And it's pretty much just an HTTP client that you can use to make requests to your API. You can use whatever you want. Some people prefer to use Postman. I like using Thunder Client because it's built into VS Code and it has everything that you need. So definitely recommend checking it out. So I'm going to go ahead and make sure I have select post as my request type, and I'll use localhost port 3000 and then /API/users. And for the request body, let's go ahead and we'll just pass an empty object because, like I said, we don't have any validation, and we're just assuming that we're passing in val data. We're assuming that the validation has already happened. If I click send, you'll see that I get back my user record. So everything works great. Wonderful. So hopefully you now know how to properly type annotate your request object with the request body, query parameters, route parameters, and then the same thing for the response type. Now, before we actually go any further, I do want to mention one quick thing, is that the actual interface for request and response should actually not come from Express, but it should actually come from Express Serve Static Core. That's because for newer versions of Express, these interfaces come from this package itself. And in fact, if you actually look over here earlier when we had app, let's do app.get, and then let's just pass in a callback function, you'll see that when I hover over here, and if I right click and go to the definition, oops, go to type definition, you'll see that it takes me to this index.d.ts file, but it's inside the Express Serve Static Core package and not in the actual Express package for the types file. Okay, so I should have mentioned that a lot sooner, but definitely make sure you have it imported from Express Serve Static Core. I don't think you might have any issues if you were to import it just from Express, but just to be on the safe side, definitely make sure you have it imported from Express, the Express Serve Static Core package. Okay, and this leads me to the next thing that I also want to mention as well, is sometimes you might want to have your request argument extended with custom properties. So for example, many of you probably have used packages such as Express Session or Passport.js. And one thing that you'll know is that in Passport.js, it has this custom user property that it assigns to the request object itself once you have fully authenticated with Passport. If you use Express Session, there's this Express Session property or session ID, and you'll notice that by default, it is not going to be part of the request object, only when you install Express Session. Okay, so I want to show you how we can actually expand or extend the request interface, so that way we can add custom properties to it. It's actually really, really simple. So basically what we're trying to do is called declaration merging. And it basically just allows us to create our own declaration file, and the TypeScript compiler will merge those declarations that have the same namespace. So that way we can actually expand our request interface that is part of the Express package. Or I should actually say the Express Serve Static Core package, because remember, that's where the actual request and response interface that by default Express uses comes from. So here's what we're going to do. We're going to go into our root directory and create a new file, and I'll call it index.d.ts. And then what I'm going to do is this. I'm going to first import I'm going to import Express from Express Serve Static Core, just like that. And then what I want to do is I want to do declare, I'm going to use the declare keyword, namespace, Express, just like this. Okay, so we are reusing this namespace Express, and then I can set the interface for request right over here, and then I can go ahead and have all of my custom fields defined. So let's just say, for example, custom field, let's just set it to string, and then now if I go to my handlers, if I go into any one of my handlers and if I reference request, you'll see that, let's see, custom field is not popping up. And the reason why that is not popping up is because, oh, I actually forgot that we need to set this as global. And let me do this. It should be like this. Okay, there we go. Now this should work. So custom field, and you can see custom field is showing up, and all the other properties should be fine. There shouldn't be any issues. You can see even in our typed request interface, I can still reference custom field just fine. And it's a string, so I can reference all these string methods as well. So that's how you can extend the request interface. You're going to see a lot of different ways to do this. This is just one of many ways that you can do this, but it's working fine and there aren't any issues. But if there are, definitely leave a comment down below or just check Stack Overflow. There usually are a bunch of different ways that you can achieve this. But I just wanted to mention this just in case some of you might be wondering, well, how do I actually extend my interface for the request? So now you know. And you can also do the same thing for response if you need to, but I don't think you'll ever find a situation where you will need to do that. Now, one more thing that I do also want to show you is when you're working with third-party libraries, a lot of times when you install those third-party libraries, they will have TypeScript support built in, as long as you install the proper types package. Okay, so let's just say, for example, we want to use Express Session, which is a very popular package that many developers use to handle sessions on the server side for Express. So we're going to go ahead and install that. So let's do this, npm I express-session. Okay, so we just installed it. And now what I want to show you is this. If I went ahead and reference request, you'll see that session does not appear. Okay, and again, if you have used Express Session before, you'll recall that whenever you use Express Session, it comes with this session property as an object, and it also comes with the session ID property. But right now it's not showing up for some reason, and the reason why is because we do need to make sure we install the types package for Express Session, because it doesn't do it by default. And that's pretty easy, so we'll just go ahead and type npm I-d at types /express session. Okay, and remember, if we go into our node modules folder, we go into types, you'll see that for Express Session, it'll have this index.d.ts file. And basically what I just told you a few minutes ago when I talked about declaration merging and extending your request interface, it's literally the same thing that these other packages will do when you install the types definition. You'll see over here, we have declare global namespace express, and then we have session store, we have the interface request, which is what we just did. And you see now it is basically extending that request interface, and it's adding this session property, session ID, and session store. Okay, it's literally doing the same thing that we just did. And all of these files, these declaration files, get merged together. And now if I go back and try to reference request, you'll see that we now have the session ID, and session store property. I'm not going to actually set up an Express Session in this tutorial, but I just wanted to show you how simple it is to work with these third-party libraries in TypeScript, in an Express project with TypeScript. So hopefully this makes sense. Now, another popular library that you will use is Passport.js, which, if you recall, when you use Passport, there's a process called serialization and deserialization. So basically, when you authenticate a user with Passport, it will serialize the user and then attach that user to the request object. And it will have this user property right over here. Right now, it doesn't exist because we don't have Passport. But let's say, for example, if you were to use Passport with TypeScript, I'll show you how you can have that set up. Well, I'm not going to actually show you how to set up Passport, but I'm going to show you the proper packages to install. So let's first install Passport. So npm I passport. Okay, and then now we need to make sure we install the types, okay, because if you look over here, if I reference request, I still don't have that user property. So let's go ahead and install types. So npm I-d types, or at types /passport. And then now you'll see that we have this passport in the types at types folder. And if you go to the declaration file, you'll see that we have, again, the same thing that we saw earlier. We're extending the Express namespace. We have this interface user, and then we have this interface request that is being extended. You can see we have user, auth info. Let's see, we have login, log out. And again, these are methods that are attached to the request object that allow you to actually log the user in, log the user out, check if they're authenticated, a bunch of other stuff. Okay, so now if I were to go back to my handler, and if I reference request, I can now see I can reference request.user. And again, this is a property that you would reference to check to see if the user is actually authenticated or not. We have request.logout method to log the user out. We have request.login. We have request.isAuthenticated, a bunch of methods that we saw from the declaration file from Passport, or the @types passport package, that we can actually use in our project. So again, hopefully you get the idea of how this all works. Okay. All right. So as promised, the last thing that I want to show you all is setting up unit tests with Jest in your Express.js package with TypeScript. So we're not going to be using Jest, but we're going to be using ts-jest. Okay, it's literally just Jest, but for TypeScript. It's very easy to use. So what we're going to do is first install Jest as a dev dependency. Now we already have TypeScript installed, so we don't have to install that. So npm i-d Jest. And now that Jest is installed as a dev dependency, we'll go ahead and install ts-jest as well. And then we'll also install the types package for Jest. Okay, there we go. Now what we'll do is we'll set up a configuration file with ts-jest. So we'll do npx ts-jest because remember, in our node modules folder, in the bin folder, we should have both Jest as well as ts-jest as a binary in that folder. So we can run that executable. So npx ts-jest config:init. Okay, and then you can see that a config file was created, just.config.js. And then you'll see over here, we have this all set up where the preset is set to ts-jest and the test environment is set to Node. Okay, so now what we can do is we can go ahead and create some test files. So I'll go ahead and create a new folder. I'll call it __tests inside the source folder. And I'll do this. Let's see. I want to create, I guess, a simple test for get users. So I'll create a folder called handlers and then new file users.test.ts. And let me just make sure that I can actually run the test itself. So we still will be using Jest as the command to run the test. It's just that it's going to use ts-jest as the preset right over here. So let's go back to our package.json file and let's modify our test script that was already provided for us. If for some reason you deleted it, or if it didn't provide this for you, just make sure you add the test script. And all you're going to do is just literally have it like this, just like that. Okay, because you're going to run npm run test, and it's just going to execute the Jest binary. Okay, and it's going to see that we have this Jest config, and it will know to use the ts-jest preset. So now if I go ahead and do npm run test, you'll see that it's going to try to run tests in the users.test.ts file, but there are no tests currently, so it's going to just fail. I could also have just did npm test, and that would have also worked as well. Okay, let's go ahead and write a simple test for our get users function. So what I'll do is this. We'll do describe get users, and then we'll go ahead and use the it function, and we'll just go ahead and say should return an array of users. Okay, so again, I'm not going to go over like the basics of how to actually write tests because I already did that in the Express course. I'm just going to show you how to actually set this up with TypeScript. Okay, but what we want to do is we want to make sure we actually call this function get users, and we want to make sure we provide mocks for request and response, or I guess we can call it stubs. So basically mock data. So I'll just do this real quick. Let's do get users, and then we're going to go ahead and do this. I'm going to go ahead and create a simple mock. I guess I'll do that inside a new folder called __mocks, and we'll do index.ts because I'm going to be reusing this. So we'll do export interface mock request, or actually, sorry, not interface. That's going to be mock request, just like this. And what I'll do is this. I will pass in mock request. And then I also want mock response as well. And let's do that. Whoops. Okay. So let's see, is it giving us an error? Okay, yeah, so right now you can see that it is giving us an error because it says argument of type empty object is not assignable to a parameter of type request params dictionary any parse queues. Okay, so the easiest thing that we could do is we could just actually cast this as the request object, and then same thing for mock response. We could do the same thing, whoops, as response, just like that. And honestly, because it's for testing, it doesn't really matter all that much, but let me just make sure that this comes from the express serve static core package. So because it's for testing purposes, it doesn't really matter so much that you're casting it. So you can just do this. You don't have to really like go out of your way and, you know, provide every single type annotation, because that can be a little bit tedious. So this is one way that you can do this. You also could actually just cast it right over here. So mock request as request, just like that. There's many different ways. If you really want to be explicit and properly type annotate every single thing, you can, but just note that it's going to be very, very tedious, because you're going to have to literally type annotate every single property in the request property, and that's going to be a lot of properties and methods. So I recommend you just cast the object to the actual request type, and that'll save you a lot of time. Okay? So let's leave it like this, and here's what I'm going to do. So essentially for our mock, for this test, in order for this test to pass, what I want to do is I want to actually make sure that the response for get users is sending back an array. Okay, so what I want to do is for mock response, I want to mock the send function. So send is going to be just.fn, and I'm not going to have it return anything because we're trying to just mock the function itself. We're not trying to override like what it returns. Okay, now right now you'll see that I am getting this error over here. It's saying conversion of type, this object over here, to type response may be a mistake. Don't worry so much about this, because honestly, again, we're using this as a stub. It's not actually going to really affect the test or the actual application in any way. So what I'm going to do is I'm going to cast this to unknown, which is what it recommends, and then cast it to a response, just like that. And then you'll see the error goes away. And then what I'll do now is this. So we're calling get users, and we know that get users is not asynchronous. If your function that you're trying to test is asynchronous, again, make sure you use async and await. So if get users was in fact asynchronous, then I would have to await this before I write my assertions. Okay, so I'm going to go ahead and write an assertion for mock response. I want to make sure that let's see, mock response dot send was called, so to have been called with empty array. So basically I am asserting that this get users function, whenever I call it, it is returning an empty array. Okay, so this test should pass. Let's go ahead and test this out. Make sure it works. And there you go. You can see it is returning an empty array. Of course, if I were to remove this, and then if I were to run the test again, the test should fail. And as you can see, it does call the function, but it did not return the expected value, which is an array. So we know that our test is actually properly failing and properly passing. It's not passing on a false positive. Okay, so hopefully this shows you how to set up a unit test. So now, finally, I'll show you how to set up Supertest for integration tests for your Express application. So this will require us to actually do some configuration changes in our index.ts file. Nothing crazy, but all I'm going to do is create a new file, and I'm going to call it createapp.ts. And again, if you've seen that 8-hour course, and if you went all the way to integration tests, you'll recognize this thing that I'm about to do. So basically what I need to do is I need to create a function. So I'm going to call it createapp. And instead of actually doing the initiation of my Express app in the index.ts file, what I'm going to, and registering all of my routes and middleware and etc. Let me actually remove this route as well, because I don't need that. Instead of doing that inside the index.ts file, we're actually going to do that inside this createapp function. So what we're going to do is this. We're going to import Express, and then we're also going to want to import the user's router as well. Okay, and because since our createapp.ts file is in the same directory as index.ts, all the imports are going to be the same. And then let me also remove these two because we're not going to need them anymore. And then we're going to take this const app and paste that inside the this create app function body, just like that. And all of the middleware, all of the route registration will go inside here, okay? And then what we'll do is we'll simply just return the app instance right over here. And then now in the index.ts file, what we'll do is we'll import create app just like this. And then we'll go ahead and do const app equals create app, just like that. And basically, when we call create app, it's going to create the instance, and it's going to register our routes, register any middleware, return that instance with everything registered. And then now we can call app.listen in the index.ts file with the assigned port. The reason why we're going to do this is because in our integration test file, we're going to need to make sure that we can actually have an accessible Express instance. Okay, so it'll make more sense once we actually set up the integration test. So what I'm going to do is I'm going to go into my terminal and I'm going to go ahead and install Supertest, because that is the library that we're going to use to set up integration tests and run our integration tests. So npm I Supertest. And actually, I want to install this as a dev dependency, just like that. Okay, and now I will go ahead and just create a new folder, and I'm going to go ahead and just call it E2E. You can call it E2E or integration test, whatever you want, but I feel like there are a lot of overlap between integration tests and E2E tests, so we'll just keep it in the E2E folder for now. And I will set up a simple script for end-to-end tests specifically. So right over here, we'll do test E2E, and then we'll go ahead and we're still going to be using Jest as the command to run these files, run these E2E tests or integration tests. And because we have our tsconfig.js or jest.config.js file, it's also going to use a ts-jest preset. So we don't have to reconfigure anything. So we're going to do Jest, and we want to make sure that we tell this script where to look for tests to run, because all of our tests for end-to-end or integration tests are going to belong in the E2E folder. So we're going to use the test path pattern flag, and we're going to pass in source E2E just like that. So it's going to look into the source E2E folder and run tests in that folder. All right, so now let's go ahead and set up a simple test. So we'll call it .test.ts. Now what I'm going to do is import request. So we're going to import Supertest, and we're going to name the actual import name request. So right now it's complaining, it's saying that it cannot find the declaration file, so we need to make sure we install the types. So let's go back into our terminal and let's do npm i-d @types supertest. Okay, there we go, and this error should go away. There we go, perfect. All right, so now we're also going to want to make sure we import create app, that function that we just created. And then inside our describe block, so first we'll set up a describe block. And let me see, we're going to go ahead and write a test to test get users. So I'll just call this users. I should probably rename index to users, but we'll just leave it like that for now. Let's do describe/API/users. And so the way that we're going to set up is like this. We're going to declare a variable using the let keyword called app. And then what we're going to want to do is before all of our tests run, okay, so we're going to use the before all hook. This is a Jest lifecycle hook. We're going to go ahead and call create app and assign that return value to app itself, okay? So you'll see that the return type is actually express. So you could actually type annotate this to be express, just like this. You just need to make sure you import that from, I'll show you, from express serve static core, just like that. Whoops. There you go. Let's see, cannot use namespace express as a type. Let me see. I think maybe we can import it from Express. Maybe this might work, probably. Okay. I'm not too sure about this, but if you guys can think of a better way to do this, definitely let me know down below. I would really appreciate that. But for now, it seems like we have our type definition, so that should be okay. Hopefully there's no issues. Let me see if I were to do it like this. Seems like it should be okay. Yep, I don't think there should be any issues for now. Okay, so now that we have called create app inside the before all hook and then assigned it to the app variable, we can go ahead and write a test. So what I'll do is this. We'll do it should return an empty array when getting API/users. Okay, and then what we'll do is we will declare a variable called response, and then remember request is a function, and this function is asynchronous. So we're going to want to make sure we're using async await. So async and then await the request call. And then we want to pass in the app variable like this as an argument to request. And then we're going to go ahead and call get and specify the path we want to actually make the request to, or allow the Supertest to make the request to. So /API/users. And then now what I can do is I can write an assertion. So I can do expect response dot body, and then I can have it do something like to be or to strict equal empty array. And let's go ahead and run this test and see if it works. So let's do npm run test :e2e. That's the script that we set up to run end-to-end tests. So you're going to see now it ran the test and it seems like it succeeded. And if I were to actually, let's say if I did like a different array with different values in the array, the test fails. Okay, so that's good because the actual return value is an empty array. Okay, and you'll notice how if I actually, I don't know why I did create app over here. Let me remove that. Okay, I shouldn't have done that there. Okay, there we go. Yeah, sorry about that. I did not mean to call create app globally over here. I meant to do it inside this before all. Okay. Okay, good. And some of you might be wondering, well, why should I do it inside the before all if it works like this, right? Because if I were to run the test again, right, everything works. Why should I do it inside the before all? So you don't really need to do it in this situation because right now we don't really have anything else that our Express application depends on. So in other words, our Express application doesn't have anything like a database that it needs to connect to, doesn't need to connect to like a Redis client or a Redis server. So we don't have to worry about connecting it to those other services. In a situation where your Express application has asynchronous calls that it needs to make to actually have the application up and running, so you might need to connect your application to a database, and that's very crucial for your application to work. You're going to need to want to make sure that your application first connects to a database, and then you want to actually initialize the app. So in situations like that, you want to make sure you do that inside the before all hook. Okay, and also the before all hook allows you to add the async keyword, which allows you to use the await call in case if your create app function may run some asynchronous code. So you cannot add async as a keyword. Over here, it's actually going to complain. See, returning a promise from describe is not supported. Tests must be defined synchronously. So that's the reason why. But if you were to do that inside before all, and if you were to run this, even though create app is not going to return a promise, it's not asynchronous, okay? But if it did, this would work just fine. So hopefully that answers that question. So let me just remove this and remove that. So that's going to be pretty much it for this tutorial. Hopefully this all made sense. I wanted to make a video to show you all how to actually set up TypeScript with an Express.js project, show you how to do all the proper type annotations, show you how, if you're going to use a third-party library like Express Session or Passport, show you how to install the proper type definitions and how you can actually reference those type definitions once you install them, and those properties that you'll be using a lot too. So hopefully this all made sense. If you have any questions, please feel free to leave a comment down below. I read the comments pretty much every single day. So if you have a specific question, let me know down below. Join the Discord server if you need extensive help. We have a community with over I think 2,000 members. So someone will definitely help you out if you have a question. So that's going to be pretty much it for this video. If you all like this video, please feel free to subscribe and like this video to help support the channel. And I will see you all in my next episode. Peace out.